So, Vanakkam, we will continue our lecture. As I told you last class, so the seismic instruments are used to record seismic waves. Okay. So, we have seen that single component seismic instrument where the vertical component of the earthquake will be recorded. So, 3 component, 1 vertical and 2 horizontal component of the earthquake is recorded. Okay. So, these earthquakes are recorded in the seismic station. Then how these earthquakes are quantified, okay? How these earthquakes are scaled. Okay? So, the low earthquake, big earthquake, high earthquake, how it is quantified. So, let us see some of the earthquake reports, okay, which is been reported. This is some of the, so the Turkey earthquakes. So, it killed around 38 people, at least 1600 people are hospitalized. You can see that the magnitude of 6.8 is actually mentioned. Okay, magnitude of 6.8. You remember they are written magnitude 6.8. Okay. So, then parallelly for the same earthquake, okay, the same earthquake there was another news. So, which is written that Elazig earthquake occurred on so and so time and the local time on 24 January Turkey, and the magnitude of earthquake was determined to be 6.7 MW. Okay. So, here it is written 6.8 magnitude, it is written 6.7 MW. Then there so many people died and all those things. Okay. So, it is written, and then they also said that the neighboring countries of Syria, Iran observatory where the magnitude of earthquake is 6.5, a total 49 people died. So, something is written. Okay. So, similarly, if you see the another earthquake, so the maybe the same earthquake where you can see there was a map which is published with there are some lines. Okay, you can see these are all the some lines and the maps are published. So, then they also given the location of the earthquake, and then I was telling you the shake map, okay, where IMD also releases is given, and also they release a warning system, okay, the pager warning system. So, about this earthquake with respect to economic loss and fatality loss. This is, so this is the generally the each earthquake report being released and reported, that earthquake information like the fault mechanism, and then how many people felt, and what was this isoseismal map, and then what was the acceleration time and all. So, this is another earthquake where it is, I think it is reported in India, Indian earthquake. So, basically these earthquakes are occurred in Jammu and Kashmir. They reported that 4 medium intensity earthquake, okay, shake Jammu and Kashmir within 2 hours, no immediate report of casualties. Okay. So, then they reported the 4 earthquake of medium intensity with magnitude measuring between 4.7 to 5.5 in the Richter scale hit Jammu and Kashmir. Okay. So, that is what the report it released. So, similarly, there is a scientific report on the earthquake kind of things. You can see here, this is about the Bhuj 2001 earthquake. So, they written that so the India was celebrating 51st Republic Day on earthquake of 6.9 intensity on Richter scale. So, you should note that 6.9 intensity on the Richter scale epicenter. So, if you glimpse I mean try to see all the 4 report. So, somebody reported magnitude, somebody reported moment magnitude, somebody reported intensity, somebody reported Richter scale, okay, somebody registered magnitude on Richter scale, somebody reported intensity on Richter scale. So, what is this? Okay, so it is really like a magnitude is a quantifying scale or intensity is a quantifying scale. There was a confusion. So, so the magnitude basically literally if you go by the meaning. So, the magnitude is basically is something which is measured as a magnitude. So, intensity is something which is intense, like the felt effect kind of things, intensity. This is a literal meaning. So, these people giving a some kind of mixed kind of observation on that. So, in order to understand and study the earthquake well, you should know how to quantify a earthquake. Okay, how to earthquake can be quantified. Okay, the concept of earthquake quantification. So that is what we are going to discuss today class. So after this class, you will be understand what is the earthquake you should report, which scale you should measure, which way you can report a earthquake to the general public who doesn't have the any knowledge. Okay. So the earthquake size, okay, can be expressed in several way. The most suitable way is actually, one is that qualitative way, the another one is actually the quantitative or instrumental way. So the qualitative way is basically non-instrumental way of representing the earthquake size, that is the qualitative way. So this practice being used before installing the instrumentation to measure earthquake, that is the qualitative way. So the quantitative way is after installing the seismic instrument at particular place, whatever record we are getting, that data is used to quantify a earthquake, that is the quantitative way or instrumental measure of earthquake. So there are two ways we will report this one. One is that intensity and magnitude. So the intensity magnitudes are not equal. Intensities are the some quantity qualifying the earthquake size or quantifying the earthquake size in qualitative manner. Qualitative manner means like approximately defining, okay, based on the some qualitative observation is the intensity value. The magnitude is basically the measure what instrument does. What instrument does? Basically the seismic instrument, we have seen that it measures a seismic wave. So how it measures? Basically it measures so like this you can measure. So depends upon the place, okay, so where it is there, so it will be measuring the signal, correct. So like this. So as we have seen that, okay, so this basically, so as we have seen that this basically arrival of P wave, this is the arrival of P wave. Okay. So similarly we can also see the arrival of S wave, the arrival of S wave. Similarly we can also see the arrival of other waves, surface wave. So depends upon the location of the instrument, you can get a particular wave type in your place. So based on this wave type, okay, you can estimate a size of earthquake, that is quantitatively you can estimate based on this record, that is called as a magnitude. Okay, that is the magnitude of the earthquake where you can sell a size. So what are those magnitude? Depends upon the what type of wave you use, the magnitude scale will be different type. So one is that basically a Richter magnitude or a local magnitude. You can see that the Richter magnitude, local magnitude, which basically developed by the Richter, we will discuss in detail. Then another one is the surface wave magnitude. So you can see that this is the magnitude which used from the surface wave, the body wave magnitude where the body wave is used here, the coda wave magnitude where the coda wave is used, the later one was the moment magnitude. This is the most advanced version of estimating the quantifying the earthquake using so the waveform data from different station without error. So in this class we are going to discuss in detail intensity and magnitude, its development. Okay. So why? Because as we have seen that until 1960 India does not have many seismic station. Even today the number of station available are very less. Because of that the intensity scale also practiced at several earthquakes are reported in the form of intensity, so that if you know the intensity value, you know the severity of the earthquake, that also used for estimating the hazard and other things. So what is mean by intensity? So the intensity basically tells how the strong earthquake feels are to the observer. So that means the intensity scales are basically made and designed such that a person in the particular location, based on his level of perception of the seismic wave, the intensities are scaled, okay, for the lower level. The higher level, this also scales, okay, the qualitative assessment of the kind of damage done by a earthquake, okay, how the earthquake caused damage. So, this was developed by the basically the MS De Rossi, Italy, okay, then the Francis Sois Fresel, Switzerland. So, they joined together and developed this intensity scale in 1880s, where there was a research started for the seismic instrumentation. So, depends upon the distance of the earthquake, strength of the earthquake and local geology, the damage changes. So, that has been notified and observed, and that used to size a earthquake. So, depending upon the earthquake strength, okay, the local geology, this intensity scale varies, determined from the intensity of shaking and damage from the earthquake. So, this is actually the descriptive scale continues to be important, because many seismic regions there is no seismogram to measure strong ground motion. Okay. Second, the long historical record of seismically active countries found on the only such descriptive intensity scales. Okay. Where the many world earthquake, as I said, that there is no recorded data because there is no seismic station. Even India, there are many earthquakes, we can say like that. Because of that, the intensity scales are very important and being continuously used. So, what are the different type of intensity scale as on people practice? So, one is that Mercalli, okay, so Cancani Seiberg scale, which is 12 level used in the southern Europe. Then the modified Mercalli, so which is like a 12 level scale proposed in 1931 by Wood and Newman, who adapted MCS scale to the California data set. It is used North America and several other countries. The another one is like Medvedev, so MSK scale basically. The 12 scale adapt Central and Eastern Europe, used in the several other countries. The European microseismic scale EMS 12 level scale adopted since 1998 in Europe. It is development of the MMI scale. Okay. So, the Japanese meteorological scale, it has a 7 level used in Japan. It has been revised over a year and had recently been correlated with the maximum horizontal acceleration of the ground. So, the road damage intensity scale, it has a 5 level scale specially developed for the roads, useful for seismic vulnerability assessment of the transportation network. Okay. So, we are going to discuss this intensity scale in detail. So, if we see overall, actually the first 4 scale has a 12 level, only depends upon the where it has been used, it has been renamed. When they use Southern Europe, it is MSC, when it used in the North America and several other countries, it is MM, and then it is used in the Eastern Europe and several other countries, MSK, and Europe it is completely, it is EMS. But overall the scale 12 level remains same. So, the another level Japan, which has a 5 level scale only used in Japan. The RDS is the recent scale, it has a 5 level, Japan has a 7 level scale, okay, it is a 5 level. So, we will discuss each one in detail. So, the overall all the 12 level, okay, so the most widely it is called as a modified Mercalli intensity scale or MM scale or MMI scale. So, this has 12 level of describing the earthquake felt observation or earthquake damages. So, what they do those days, they will train some person, okay, then based on that person perception, he will tell that what is the intensity of the earthquake if there is no damage. You can see that the level 1 detected only by the sensitive instrument. So, when there is no seismic instrument, so generally the level 1 never been reported, it is not at all there, but since you cannot start with 4 or 5 as a scale. So, the level 1 has to be there. Level 2 felt by the few person at rest, especially upper floor, okay. So, delicately suspended object may swing, this is the level 2. Level 3 felt noticeably indoor but not always recognized as a earthquake. Standing autos rock slightly, vibration like passing a truck, that is a level 3. Level 4 were felt indoor by many, outdoor by few, and might some may awaken dishes, windows and door disturbed, motor car rocks noticeably. So, this is the where the human can feel, if they felt, all the people in particular area felt a vibration, that will be the intensity 4 and 3. Before that they cannot feel. Okay. So, the felt most people, okay, some breakage of the dishes, windows and plaster and disturbance of tall object, where you can start noticing the building damages, building damage on 5 onwards. So, that means somewhere its intensity 5 is reported in the history, there may be a damage of the building has been noticed during that earthquake. So, 6 felt by all, many frightened and run outdoor. So, falling of plaster, chimneys damage, all those things are 6. 7 everybody runs outdoor, damage buildings, varies depending upon the quality of the construction, noticed by the drivers and automobiles. So, 8 panel wall throw out of the frame, so false wall, window, monument, chimney stand, mud ejected, drivers. So, these are all the some of the ground deformations also occurred in the 8. So, 9 the buildings shift of foundation, cracks and have a greater damage. Okay, so, where underground pipes broken. So, 10 most masonry frame structure destroyed, ground cracked, rail bent, landslide. You can see that the landslide and railway network come into the location of basically scale 10. 11 few structure remain standing, bridges destroyed, fissures like bridge, pipe broken, landslide, rail bent. So, 12 damage, total waves, seen ground, surface lines, slightly level, destroyed, object through. So, you can see that the description what they observed in the several earthquake has been put together to frame this intensity scale. Okay. So, that is what it says. Sometime you may specifically get this kind of definition, you may not get. For example, so India, most of the places we have the predominantly mud structure. Okay. In the same city you can also see a RCC structure, reinforced cement concrete, and plain cement concrete structure. If these 3 structures are behave differently, so which scale you should use should be, you should have the knowledge. You cannot write all together same place the magnitude 6, 7, 8, that is a wrong. Okay, that you should know. So, this scale, okay, so for the mapping purpose this scale also used in the color grading, you can see the color grading. So, the light blue, okay, so the light green, green, yellow and red, light red, dark red and then very dark, so reddish black. So, where you can see the extreme 12. So, by using the color coding one can able to see the what magnitude, what intensity has been expected in this region. So, if you go back to the first slide, okay, here you can see the color coding. Now, you understand why the isosysmal maps are color coded on different level. So, by seeing this you will understand how the damage is severe at a particular location. So, now as on this class going on, you may be seeing that each day, okay, so they release a COVID-19 ward update map. So, they map basically red, orange and green. Okay, so, the red means there is a active case, orange means it is basically active case passed the first quarantine period. Then okay, green means there is no active quarantine cases. So, this also they use a 3 grading system, most of the state and then the city level they release this kind of map every day for the make mobility easy planning and all those things. So, similar way this kind of color coding map help easily to understand how the earthquake is caused damage. So, you look at all this scale basically. So, you can see the damage level expected in the building and then a different scale. So, even though there are a scale which is 12 in nature, but this 12 you can see more or less this goes up to 4 There is a slight difference is there, after 4 it is almost same. Okay. Then the MSK scale you can see, it is a Japan scale and then Roseforel scale, there is a difference. So, more or less anything which reports the building beyond 50%. So, it will be called as a intensity 10 and above in the 12 scale, and but it is 6 and above in the Japanese scale of 7. Okay. That is a comparison you can get from this figure. So, this intensity scale, okay, so used to plot a equal intensity. Okay. So, then join a equal intensity through a line, that line is called as a isoscemal line. Okay. So, nowadays these intensity scales are basically used to, so these intensity scales are basically used to convert to magnitude. There are some equations people have developed based on the, so their regional data, and then they given. So, where if you have even the old MMI values which you can use to convert to the acceleration for the design purpose and engineering analysis. Okay. So, this acceleration basically peak ground acceleration or 0 period acceleration, maximum amplitude of the recorded acceleration, which we will discuss in the interpretation data time, what is the peak ground acceleration and 0 period acceleration or maximum amplitude recorded acceleration in detail. But now we should know that there is a conversion between the engineering quantities or quantified way of earthquake measurement of acceleration to the intensity using these relations. So, this is the basically the acceleration in Gauss, okay, with the respective intensity scale. You can see how the intensity scale. So, this was basically reported by the different earthquake recordings, and then there was a some kind of normalized table has been derived for this. So, this intensity scale, okay, basically affect the accuracy of the intensity rating. As I told you that they train a people and ask them to tell the intensity value. Sometime, as you know that among the people itself there are people who are very sensitive to the sound and vibration, there are people they are not even sensitive to the any kind of vibration signal. So, depends upon the person to person, this intensity scale may vary. It is not straightforward same at a different place because of the perception of the people and the sensitivity of the people. When the study of intensity earthquake was made nowadays, its question is that at particular town or village, the effect reflecting the greatest intensity often chosen those increasing the local rating of the earthquake. A particular difficult to use landslide caused by the earthquake, the modified Mercalli intensity gives landslide rating of 10, but the fact is the landslides are common many region, even non-seismic areas, okay, where the landslide may taking place, because the landslide sometime occur due to the rain. Okay. So, due to the rain the slope is saturated and become a less shear strength slope. When there was a vehicle goes small, that vibration causes a landslide, but the intensity 10 says it is a very highest level. So, such kind of ambiguities are always occur, and moreover these intensities, for example, I told you that in the same place you have the mud building, RCC building, and then the normal brick wall construction houses in the given urban area, all of them are located within the same line. It is very common in India. The mud building completely collapses, other two buildings has a crack. What intensity scale you will assign? That it depends upon the person who survey the house. Okay, he will preferably give the highest range, but it may not be right. Okay. Sometime, so there was a experience which I gained during my visit to Sikkim. So, where there was a traditional construction house. Okay, the traditional construction house, how they constructed the house basically in Sikkim hilly area, they follow their own traditional way of bringing. So, basically the hills are having slope like this. Okay, so, how they constructed the house in the traditional way? So, they made like the wooden frame like this. So, then they made a wooden frame. So, in this they put a wooden roller kind of wooden rod tree, only chopped the branches. Then again they made a wooden frame and again they build a house with 2 floor. Okay. Then they had a window, that window was braced. So, this all completely wood like this. So, it completely wood with the frame and door openings and all. Then followed by this are wooden panel plastered with mud with cow dung or a cement paste. Okay. So, in that same place basically, so this was the road. Okay. So, in the plan this road was basically extending like this. There was another place where the RCC framed structures are constructed, which was basically some Christian church in the same area, which was not very far, about 100-meter distance. So, when we went to do the observatory survey soon after the some earthquake, basically this house had not even a minor crack, but this particular house completely had a damage. So, now which one you will take into consideration making the intensity scale. So, even though this is according to engineering point of view, which is not a pakka engineered structure, but it is concrete to be believed, RCC building to be believed to be a engineering structure, but it has a damage, it does not have damage. So, this kind of complicated situation will arise, okay, where the judgment person who is doing the survey will take a role to decide what is the intensity scale. That was the one big problem in the intensity scale. Okay. Actually, this is the traditional practice, even though it is not non-engineering structure. This is the traditional practice, even though it is a not non-engineering structure, but since people there see they know the earthquakes are occurring in that region, they used this wooden as a base connecting 2 floor, one with the connected with the rock, another is house. So, this when earthquakes are occurring, basically this rolls here and there. So, which is basically makes house intact, not creating any damage. So, this is the traditional practice where northeast people are using, but nowadays because of this concrete jungle or concrete knowledge to the people, many people knowingly unknowingly believe that concrete houses are stronger, but it is not so. Okay. Concrete maybe you give aesthetically a good appearance and view, but this kind of scenario where the concrete house actually collapsed completely, but this was intact. Okay. If the concrete house not designed as per engineering design requirement, it is disastrous. Okay. But the traditional house, even though it may not be the scientifically having the equation or with the design parameters, but since it is the traditional practice, it survived the earthquake. So, this kind of issues will come when you assign a intensity scale damage level based on the building. There was another situation where the earthquakes are occurring in the forest. Okay. There was a many place, you know that there was a forest. If the earthquakes are origined in that place, okay, it propagates. In the forest, no man will be living and no house will be there. So, then how do you people know that these earthquakes are happened or not? If the forest is having like a 200-kilometer radius forest is there, so you may not even feel the earthquake, but that earthquake may be very stronger. Okay. Means since there is no people there, there is no report, that does not mean that there is no earthquake. So, that is what happened when you have the poor seismic instrumentation since historic time. You might have missed many earthquake which has happened in the remote area like a sea as well as in the forest or non-habited places. So, that is where you may not notice and recorded that values as a earthquake, but that might have happened and that seismic history may continue in that region. Okay. So, that was the issue. So, as I tell you that isosysmal line. So, the isosysmal line is basically the equal intensity connected grid line. Okay. Line which is connected is equal intensity is the isosysmal line. The map which is showing a several isosysmal line is called as a isosysmal map. The in seismology, the isosysmal map is used to plot a equal felt intensity and generally measured modified intensity, and then they give a color coding depends upon the intensity level, which will help you to identify where was the origin of the earthquake. Basically, the higher and concentrated places like this will be the historic, okay, so location of the epicenter of that earthquake. Based on that only they will define this is the epicenter of the earthquake, okay, based on the known knowledge. So, this is the typical isoseismal map, okay, for the 1968 Illinois earthquake. So, this isoseismal map, people found that the isoseismal map reported in the area and well match with the geological data of the region. This is basically a San Francisco intensity map. You can see the San Francisco intensity map, San Francisco geology map. You can see there is a similarities which you can understand much better in the color scale. This is the fault when earthquakes occurred, this is the this one. This is the thickness of the soil like rock, okay, bedrock and then soil thickness. You can see that, so wherever there was a high intensity, okay, there was a deep soil found in that region. Wherever there was a low intensity like this block spot, you can see the less bedrock or surface rock region where the damages are less. So, provided your buildings in this area throughout the regions are similar. So, you can also understand the role of geology and soil in the region using this kind of studies. So, this was the origin where the earthquake geotechnical engineering started. People try to understand how the earthquake, okay, so influenced by the soil in that region. The earthquake damage is responsible from the soil deposit in the region because of this kind of observatory data, comparing with the geology and the intensity of the these earthquakes. So, this is about the intensity scale standard way where the building damage and then the report of earthquake has been being reported. So, these are all about the, we said that there was a 4 type of intensity scale, all of them have 12 level. There is a Japan intensity scale 7 level. Since the 12 level is most widely used, we are discussed about the 12 level. We also talk about the isoseismal value, isoseismal map, problem with the intensity scale. Okay, so how the intensity scales are helping to identify the geology in the region if the buildings are similar. Okay, the next class we are going to discuss about the road damage intensity scale, okay, which will be developed by myself. Okay, so I will tell you why I developed in the next class. So with this class we will thank you. We will meet in the next class. Thank you.